Hello, Honors Chemistry, and welcome to Chapter 5, Section 5.5 through 5.7, where we talk about ionic compounds, and specifically the naming and writing formulas of ionic compounds. But just to refresh before we do that, so ionic compounds are composed of a metal and a nonmetal, or a metal and a polyatomic ion, or two polyatomic ions. From there, it can be type 1 or type 2, depending on whether or not it is one of these metals or any other metal. And then from there, it can be either binary or polyatomic ion. Yes, based on if it's made of two elements or more than two elements. All right, so now let's talk about, in the previous one, we talked about type 1 binaries and type 2 binaries, where we use the full name and then root and ide, right? So we did sodium chloride versus iron 3 oxide, right? So here, again, we have a metal, right? We would look at our periodic table if we weren't sure, right? By the way, that's one of those things I meant to do and I forgot. When we look at our periodic table, we are just going to use this line for the purposes of naming, because we don't have a separate section for metalloid naming, right? We are just going to say if it's on this side, right? If it is to the left, right, it's going to be a metal, right? If it is to the right of that line, it is going to be a non-metal, right? Just to keep the naming simple, right? That's how we're going to divide that table up, okay? So if we look here, sodium is definitely a metal, and then we would see sulfate, and we'd be like, oh, well, that's weird. I don't know what to do with that. Oh, that's right, because then it would click that that's on that list of polyatomic ions, right? Copper is a metal, right? Nitrate, but we have this here, which means it's a ding, ding, ding type 2. Here, right, when we look at the formulas, we'll see again, right, we have 1, 2, 3 elements, right? 1, 2, 3 elements, which again tells you that there must be a polyatomic ion involved. Once your polyatomic ions are well memorized, that should get even easier, because it's not like you're going to count ions. You'll just see, ooh, sulfate, ooh, nitrate, and that will be even easier. But anyway, so this is a type 1 poly, right? This is a type 2 poly, right? If we look at the naming systems, right, we are still using the full name of the metal. And if we look at the polyatomic names, right, if you've memorized them, what do you notice? Right, we're also using the full name of the polyatomic ion, right? So in terms of our naming system, that's what we would fill in, right? We are using full name here, right? Full name. So these are even easier, kind of, right? We just have to memorize them. That's the only hard part. And we are still putting the charge here, right? Charge of metal in Roman numerals. Oh, geez. Okay, pretend it says all the right words. All right, okay. So then let's dissect the naming just to make sure we understand it like last time, right? So we would see this sodium sulfate. Now, in terms of clues, right, we have this metal. In addition to having that metal there, we also have another clue, right? This ends with 8, right? That is a clue to you. Oh, only polyatomic ions end with 8 or ite. So that's a clue to you, right, that it's a type 1 poly, right? Likewise here, right, I should have used a different example, right, but nitrate, right? So let's go ahead. The writing of the formula works the same way, where it's about the balancing of the charge, right? So here we have our sodium sulfate, right? So sodium has a charge of 1 plus, sulfate is 2 minus, and so it'd be 1, 2, and we would need to see how many we need of each, right? We would need 2 of those sodiums to give us the same magnitude as 1 sulfate, right? And note, that's why we have the 2 there, right? Likewise, if we look at copper nitrate, so that 2 gives us the charge of copper, because copper is in the type 2 metal section, right? So we have a 2 plus, and nitrate, once we've memorized it, we would know is 1 plus. So we have 2, and we have 1, and then obviously the balancing says we need 2 of these, and so we have a 2 there, yes? And note that that 2 has to go outside of the NO3, right? Because NO3's formula, right, is that. So there's nowhere to put a 2 that indicates I need 2 of them except by doing this. Yes, does that make sense? That says I need 2 nitrates to balance out that 1 copper. All right, so now let's just go ahead and do some practice, right? So these are the ones that are in your guys' outline. I do recommend that you do them, or you give them a go first, right? And then we can do them together. So if we're going to name these ionic compounds, so which one's easier? Let's do the formulas first. Write a formula for each of the following. So First, we are going to ID if it's ionic, right? And then we're going to do type 1 or 2, right? And then we're going to do binary or poly, right? And that's what we're looking for. So potassium and iodide, right? So iodide is a clue, right? What does that tell you? Right, it tells you that it's binary, right? And potassium is a metal. Iode comes from iodine, right? So we know that this is potassium, which has a charge of plus, iodine, which has a charge of minus, right? We would know that from looking at our periodic tables, right? Let's just go ahead and do that, right? Let's clear this. Okay, so when we look at our periodic table, potassium here, iodine here, right? +1, and again, this is -1, -2, -3, right? So we get the charges of our species, and then we just need to make the charge balance, right? So again, 1 equals 1, which means I need 1 of each. Ki is my formula, yes? Strontium chlorate. So I see that 8 here, and that 8 tells us, right, polyatomic ion, right? And strontium, we would go find strontium. Strontium is right here, right? So that's a type 1. So we have a type 1 polyatomic ion. So strontium is Sr, 2+. Chlorate, we would need to think to ourselves, and hopefully we would be like, oh, ClO3 minus. So I have 2, 1, which means I need 2 of these. So strontium, chlorate, 2, yes? All right, because we'll never change the subscripts inside of the polyatomic ions formula, right? ClO3 is the formula for chlorate, right? Just like, you know, your name is spelled with however many letters it is, right, in whatever order it's supposed to be, and you can't change that, right? Same thing with chlorate, right? ClO3 is chlorate, but we can have more than one of them, right, by using parentheses and a subscript. All right, gold 1 acetate. What do we see here? Right, this is always going to be a giveaway to you, right? Type 2, that's always going to really easily be the charge of that metal, makes life easy, right? Acetate tells you, right, that 8 ending tells you, ooh, this is a polyatomic ion, right? So gold, it already tells you here, is a +1, right? Acetate, that's that C2H3O2, charge of -1. So then we have, we'll just do this, 1, 1, right? So we need 1 of each. So gold is Au C2H3O2, and that's the formula there, right? Lithium nitride. So we have that. We have lithium. If we go look at our periodic table, right? Lithium is right here. So definitely we have a metal, group 1. The dog got excited. We'll pick up in the next video with the rest of this practice. Thanks for listening. Be good, and I'll see you soon. Bye.